Okay, in this video we're going to be looking at basic addition facts models. We're going to talk about counting on, doubles, making 10, and counting back. Okay, the first model we're going to look at is called counting on. And to do this, to work with this model, I'm going to use something called color tiles or color counters. Sometimes you can color counters are typically either square in nature or round, and two different colors. Typically the two different colors are used when you get to integers, and all I'm going to look at is modeling two different numbers. So I'm just going, they're both positive numbers because we haven't started with integers yet to actually look at negatives. So I'm going to model the number 6. 1, 2, 3, 4, 5, 6. Okay. Now, depending on the level of sophistication of the student's understanding of the concept, they may employ two different techniques. Okay, I'm going to go ahead and put the 3 there. So over here on the left, I have 6. To the right, I have 3. So typically, if a student is using the counting on method or model, they'll actually count out 6, and then to add 3, instead of laying all 3 down like I did, they'll lay them down one at a time and count up from 6, which means with this one place, then this would be 7, 8, 9. So they would start with 6 and then go 7, 8, 9. So they're counting on from the last number. Okay? Now, students will also count, and it's not counting on, but I want you to see the difference in the level of sophistication of the model, or the method that goes with the model, because to the left-hand side we have 6, to the right-hand side we have 3. So if I have a student that counts out 6, counts out 3, and then goes back and does 1, 2, 3, 4, 5, 6, 7, 8, 9, that's not counting on. That's just counting the total together. Counting on involves, again, laying the first 6 down and then putting the next 3. So they might count the 3 out here and then go, or count them 1, 2, 3 in their mind. And as they're counting in their mind that 1, 2, 3, they go 7, 8, 9. So they have 2 piles, and then they lay the greater number down and then add on the smaller one. So if you wanted to model, for example, then 5 plus 2, the student would lay down 5, and so then they've got this pile over here that has 2 more in it. So to get the total, so they're counting a pile of 5, a pile of 2, but then what they do to get the answer is to go 5, 6, 7. Okay, so that's the counting on model. Okay, now the doubles model is one that students typically have a good understanding of doubles. In other words, they understand what 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5, 6 plus 6. In other words, doubling the number is. So if they look at the number 6 plus 8. So this is a pretty sophisticated level of knowledge about the math concepts themselves, because they see 6 plus 8, they see, oh, I could do 6 plus 6, which is 12, and 8 is 2 more than 6, so then I add 2 more on, and that gives me 14. Okay? Now, they might also see, if they have an understanding of the concept of subtraction, at the same time they're dealing with this doubles concept, then they could say, okay, 8 plus 8 is 16, and 6 is 2 less than 8, so that means I need to take away 2. and get 14. So this is a little more sophisticated than this, but both are still the concept of looking at doubles. Now, if you're teaching only addition when you do this, and you're teaching in lower grades, then what you're always going to want to do is look at doubling the smaller of the two numbers. Okay, so for example, let's look at 5 plus 6. All right, so we're going to think about doubling 5. So that would be 5 plus 5, which is 10. And I've got 6, which is one more than 5. So then I'm going to add 1 and get 11. Now, the thing that you need to see that's so important here, though, is this whole idea that if a student looks at doubles based on this kind of concept, addition based on the concept of doubles, at some point in time they still need to make that connection between the fact that I can do 6 plus 6 and then it's 2 more, which will be 14, but I still need to understand that 6 plus 8 actually is 14. Now, I'm not advocating memorizing addition facts. What I am advocating is the fact that once the student has the knowledge and has the conceptual understanding of what 6 plus 8 actually is, then they need to learn and be able to say 6 plus 8 is 14. Because math power, which is one of the concepts in the NCTM standards, mathematical power is only conceived for a student when they actually can understand, and when the teacher says, Johnny, what is 6 plus 8? And Johnny answers 14 without having to sit and do the mental math of doubles in their head. Now, this won't come immediately, but after repeated use of the model that they're using, if it is doubles, eventually power's equated from fluency, and fluency is doing a lot of it. So lots of practice will get students to the point where they have that conceptual understanding that 6 plus 8 is just 14. Now, the other way that students equate and begin to build that conceptual knowledge is to look at how does the fact relate to 10. So in this case, if we're trying to add 8 plus 3, then the student can see, okay, all of the sum, the add-ins that will give me a sum of 10. Excuse me, a sum of 10. And I know 8 plus 2 will. But then I see that 3 is one more than 2, so 8 plus 2 is 10, and then one more is 11. Okay? Or I could look at 9 plus 4. Okay, 9 plus 1 is 10, and 4 is 3 more than that, so 10 plus 3 is 13. Again, this is sophisticated thought processes, okay? These are sophisticated thought processes because the student has to have a clear conceptual understanding of what the number 8 is, what the add-ins are that give me 10. Okay, so this is just a strategy. Now, I will tell you that making 10 is typically a strategy that's used when we do double-digit addition. Okay, specifically, students would look here first at this 4 plus 6 and say, oh, that's 10. And now I have 3 more, so that's 13. And then we look to the tens column and I see, oh, 9 plus 1, that's a 10. And then I've got 4 plus 2 is 6, so I have 10 plus 6, which is 16. So this is a level of sophistication when we're doing single-digit addition that is applied typically when you do double-digit addition. Now, again, students also have to have a clear understanding that the commutative property works here, because if I take these two are in order down, so we have 4 plus 6, we know that's a 10 plus 3, but when we looked at doing the tens column here, I didn't add 1 plus 2 and go in order. I picked these two here. So I did associative by grouping those two to get 10, and then I changed the order as well. So I use commutative and associative properties both to do the double digit addition. So that follows from understanding this concept of making 10. Now, counting back is another way that we could look at, like we did making 10. So here we count back from 10. So I think here, okay, 9, that's close to 10. So what is 10 plus 4? 10 plus 4 is 14. But I need to count back 1 because 9 is back from 10, or 1 before it. So if I count back from 14, then I get 13. Or 14 minus 1 is 13, so I'm taking away. So this is a pretty sophisticated way for students to look at, because that means they understand the concept of add or take away, either one. And these are the models of addition. So we have counting on, we have looking at doubles, making 10, and counting back.